Good afternoon, everyone. Thank you for being here today for this session. My name is Renaud Mathieu. I'm an Android software engineer based in Paris, and I'm currently working at LifePay, a secure mobile payment application. We integrated a scan and go feature to our app recently, and basically, scan and go is a feature where any user can scan items in a store along the way, and then pay and head toward the exit, avoiding waiting at the checkout. So this talk, of course, is about how to effectively scan barcodes and Android. So this is Android current status. We have so many apps just to scan barcodes, and why that? Because there is no out-of-the-box solution within the Android framework to easily scan barcodes. I mean, okay, I have a Pixel device, I have Google Lens, so when I start the camera, I can use Google solution. And I think there is something similar for Samsung and Huawei. And also, our dear iOS developer friends, they have a very simple way to scan barcodes because they are using the camera API from their device. And looking at the Play Store right now, I believe that most of the apps are actually using the same barcode detection engine. So we will see through this talk the different implementation available on Android to scan barcodes. Before that, I'd like to give you some context about barcodes and talk a little bit about the history of barcodes. The idea of the barcode originated in the 30s and with a thesis paper by a guy named Wallace Flint. He was a Harvard business student, and he invented the automated grocery system. So basically, he was using punch cards and throw racks. And then it was automatically dispensed products. In 1949, Norman Woodland and Bernard Silver, they patented the barcode idea. So in the picture, you can see a bull eye, which is cycles. It's like a barcode, but with cycles. And the idea was the Morse code. What if dots and dashes had been used to communicate information electronically? They built a prototype in Woodland's own house, and by using a 500 bulb and an oscilloscope to read the code. And you can imagine that the whole thing was the size of a big desk, and it worked up to a point, but they were lacking a computer at that time. In 1952, they asked IBM to purchase the patent as to get proper funding, and IBM refused, and the patent was instead purchased by RCA, which is actually the Radio Corporation of America, and is now known as General Electric now. And there was an issue with the bullseye barcode because at that time the printers, they were not perfect and the ink was bleeding. And it happens, a new technology arrived. It was the laser, and it was faster and with less errors. So IBM was in charge of developing a new scanner, and bye-bye the 500-watt bulb. They presented a universal product code to the supermarket committee, and the proposal was accepted in 1973. A year later, the first item marked with an UPC was scanned at the checkout of a supermarket. And it was, I think, a box of chewing gums. And as soon as you start to consider that Americans are doing universal standards, then you can imagine that Europe is like they want to do also their own universal standard. So a year later, a committee created the European article numbering, and basically it was a superset of UPC. And I think the first 2 or 3 digits of the EAN barcode are for the country code, so you can know where the article is coming from. But basically, any UPC barcode can be converted into a EAN13 barcode. The data matrix code was launched in 93, and it's a 2D barcode, and it can store a large number of data for health security, traceability, etc. And the QR code, which is actually the quick response code, is a trademark, and it's a type of matrix barcode which was designed in 94 by a company working for Toyota, and the idea was to actually follow the path of spare parts when they are building cars in Toyota factories. Symbology is the system of symbols used to encode or decode a barcode. Basically, it's the mapping between messages and barcodes. There is more than 100 different barcode symbology at the moment. And I'm not sure about how to categorize symbologies. I found different classification system online, but I would consider 3 types: linear, stacked, which means many linear above each other, and 2D, like Aztec code for train tickets in France. At LivePay, we have several barcode scanning use cases. We have, of course, Scan and Go, which is a continuous scanning on barcode resolution. Barcode resolution in this case means I scan a barcode and I know by calling the server that this is, for example, a jar of strawberry jam and that it costs more than €2. We allow our user to set their loyalty program membership within the app, and they can use it as a wallet, or better, the loyalty program can be automatically applied when you're paying with the app. And of course, there is LivePay payment, which is the main feature of the app, and it allows you to pay even offline. These use cases help us to build some design guidelines to ensure our user won't be confused. And luckily for us, last year during the I/O, the material component teamed up with the Firebase team to build design patterns around barcode detection. They consider that a live camera barcode scanning happens in 3 phases. The first one is sense, meaning you use the camera to look for input. So basically you have the preview and you have information on the top, like enabling the flash mode, for example, and you have a tooltip on the bottom, point your camera at a barcode. The second step is recognize, which is detecting a barcode. And the third is communicate, display the barcode result inline or on another screen. For the scan and go feature, we want to have continuous barcode scanning. So it's better for us to have this kind of bottom sheet and not going through another screen. You can find everything on this link. It's very nice and it's specific to machine learning. So in our case, it's more about barcode scanning, but there is also some tutorials for face detection, etc. So let's go a little bit deeper now and how to implement a barcode scanner on Android. I consider there's 3 main components when you're detecting barcodes and building an app to detect barcodes on Android. The first one is camera. The second one is frame processor. And the third one is engine. So basically, you give to the engine a bitmap. And this bitmap, the engine will pass with algorithm and try to find a barcode. And if it succeeds, then you provide some feedbacks. If it fails, you ask the frame processor to give you another bitmap. And the camera gives the frame processor some bitmaps and also resolve and show the preview. At the moment, we have the camera API, which is deprecated. We have camera 2, which is, for my opinion, kind of hard to use. We have the brand new camera X, And also we have this library I've been using for more than a year, and I think it's quite nice. It's an open source project. I think it's one guy from Italy, and now there's a lot of contributors and stars online. And the project is quite fine, and we will see how to use it during this talk. So this is the camera. And for the frame processor, we have camera X also, and camera view comes with a frame processor as well. For the engine, we have zebra crossing. I think most of you are familiar with zebra crossing. It's a project now managed by Google, but it's in maintenance mode, and it's kind of the main engine we have online. But they built and gave us the Firebase ML kit, which is, I think, built on top of mobile vision API, and it's part of the kit solution for machine learning. But actually, it's not really using machine learning at all. So if we look at camera frame processor, we can use the same libraries, but we can have whatever engine we want. And so basically, I'm doing a pair of camera engine and camera view, camera X, and zebra crossing on MLKit. And we will see the two solutions we can handle to implement a barcode detection in our app. But first, what about the status of the libraries? Zebra crossing is in maintenance mode. And so it means that Google is supposed to fix bug fixes, which is not the case, because if you have been using zebra crossing and your main SDK is on Lollipop, then you figured there was some crash, and it has been there for years and they didn't fix it, which is weird. So you can't use the latest version. MLKit is in beta. I think it has been in beta for 1 or 2 years now. So it's pretty solid, actually. I don't know why they still are putting it in beta. Camera view, I put a question tag here because it's a third party. It's something developed as an open source project. So I hope the project continues to grow. For now, it's a very solid project, so I hope it stays the way. And Camera X, it beta last week, so the API won't change every version, hopefully. So let's start with a small project. I'm going to put all the dependency here. So what we will need is, of course, the lifecycle Android X artifact. For this example, I'm going to use RX Java. And then I had all the camera X dependencies. So you see they're on beta 2. I'm using also the MLKit artifacts, the camera view, and zebra crossing. Then we will create a model. So we have a barcode model with value and symbology. And the symbology is an enum of all the type the engine is able to find. So basically, we have all these symbologies available from zebra crossing or MLKit. So let's try to create a barcode detection using camera view and zebra crossing. And for this, what I'm going to do is I'm going to create a custom view. Let's call it O camera view. And basically, it extends camera view from the library camera view. And I'm creating a property to know if it's posed or not. And basically, it's just to manage the frame processor. The frame processor here is the frame processor from the camera view library. And I'm setting the lifecycle owner. And then it's quite easy for me to pause and stop the frame processor and start again the frame processor from the library, thanks to lifecycle artifact. I need this interface, then barcode analyzer. So it's just a callback on barcode scan, and that proposes an observable of barcode model. And now let's go inside the engine with zebra crossing. And using zebra crossing, I need a multi-format reader first. So basically, it's all the algorithm to detect It's the configuration of all the algorithm to detect barcodes in a bitmap. I have inside this method decode with state, and basically you use a binary bitmap in it, which is a specific object from zebra crossing. The binary bitmap is using a binarizer. Binarizer is using a luminance source, so you have to create all these objects. And the luminance source, you have to specify the width and the height of your byte array. You have to provide also a luminance source. For example, I'm using planar UV luminance source. And then I'm creating a method called detect in image single orientation, because I can switch the byte array to have to rotate the data. So I create a source, a bitmap, a result, and then I'm setting the multi-format reader. And here I'm wrapping everything into an observable for Eric's purpose. And then I create a zebra crossing image analyzer, which extend barcode analyzer. And I'm setting everything into a published subject, and then I'm flat mapping the detect in image, and then I'm mapping into a barcode model. And then I'm adding the zebra crossing image analyzer into my custom view. And that's it, it's working. Now, let's see about how is it working with Camera X plus MLKit. First, we have to know that Camera X library is still in beta stage. So it means they won't change the API, and it's not really ready for production. They say so, but it's still in beta, so be careful. And Camera X is in addition to Jetpack. So basically, it's built on top of Camera 2, which is, I'm not sure if it's a good idea at the end, but still, it's a better API than Camera 2. The concept is having use cases. So they implemented 3 use cases: a preview, a use case to analyze image. So we're going to use the first and the second use case and take pictures or video. What is great, it's all the use cases can be combined and active concurrently thanks to the executor object from Java. And basically, when you're setting Camera X, you have to create a Camera X config first. And what is funny from this is at the end, it's setting everything as well as default use cases. So in our case, it's image analysis, image capture. So it's setting everything up for us. So this is the code from the Android X library. And I can create, like I did for camera view, a custom object, a custom view called X camera view, and I extend preview view and also barcode processor. And then I'm setting everything up. So I need to create a camera provider. I need to select the camera, which is in this case the facing back. And what I have to do is use this bind to lifecycle callback. This bind to lifecycle is using a camera selector and has an array of use cases. And then I can bind all the camera and use cases to my lifecycle from my custom view. So basically, bind to lifecycle is quite straightforward here. I have a preview, I have a camera, and everything here is context as lifecycle, camera selector, and just one use case preview. And with this, I have already the surface view set, and I can see the feedback from the camera in my app. So now I need to bind this with MLKit as an engine. And MLKit is nice because it reads more standard format. It extracts structured data. It works with any orientation. And also, starting from 24 version, they introduced a new barcode scanning model, which is far better than the previous one, and also far better than zebra crossing on a performance purpose. But be careful, because MLKit is still in beta. We have seen this, but it has been in beta for years now. But the most important thing is MLKit still requires a Firebase project. So if you don't have play services, then it won't work. So basically, it's kind of the same thing as before. We are creating a Firebase image analyzer. So it's not a zebra crossing image analyzer anymore. So we have to implement the on barcode scan. And then it's quite straightforward here. What you have to do is create options. So in this case, I'm setting format all formats, which is not good at because it means that as soon as I get a bitmap, then I will try to apply all the algorithm. So if I'm setting some subset of symbology, then it will be faster for me. So the same here, I have a published subject also, and I'm creating a detector, Firebase Vision, get instance, get vision barcode detector, and I'm setting the option. And then I have to override the analyze with an image proxy method from the image analysis.analyzer, which is actually something used in the use case of camera X. And with this, actually, it's done. I just need to go back to my bind to lifecycle method. I create an image analysis, and I set the analyzer here, and I used this image analysis use case, and I add it to my camera value variable here, and everything works fine. Now I just need to implement analyze method, which is actually here. Basically, we need to have a media image. And what is great with MLKit and Camera X is I can benefit from this method here, Firebase Vision image. And from media image, I can convert an image, which is actually here, into a Firebase Vision image. So I don't have to deal actually with byte array to manipulate this kind of data. Everything is already done and done by this method from media image. And then I just have to come from my detector, detect in image. It needs a Firebase Vision image. And then it's just about success or failure. So I can convert into a barcode model and send it thanks to the published subject I defined in this class before. And then I send the barcode model directly. Another thing is, in this case, I have to close the image here. Why? Because inside Camera X, there is a frame processor, and it's working as the same way as a back pressure for RxJava. So you have two strategies, and in this case, the strategy is to keep only the latest. So when I'm calling image close, it means that actually I'm trying to get a new image. So it's used when there is a failure, for example. And then I go back to my scan activity, for example, and I just, in this case, vibrate when I get success or log when there is an error. And just using inside my XML, I can add an X camera view, or in this case, a O camera view, and both are working fine. It was a little bit fast. Thank you for listening. I have a question, and if you have question, I will be glad to answer it. And I will provide you the source code just after the presentation. Thank you. In our company, we implemented MLKit with Camera 2, but some Chinese devices don't work because they can't download the barcode model. Is it the same for you? We don't, sorry, and we are not working with Chinese devices. I mean, oh no, sorry, but some Chinese devices don't work. No, we don't have any problem with this. Okay. Okay, thank you.